we have a dartboard. Suppose we randomly throw a dart on this circle. So randomly means that every single point has equal likelihood for the dart to land on. And the rules are that if we throw a dart, if it lands on the green region, we get 1 point. If the dart lands on the orange region, that is worth 5 points. And if we manage to throw it inside the blue region, that would be worth 10 points. The radius of all three circles are given, and they have the same center. So first, the radius of the blue circle is given to be 10 centimeters. The radius of the second biggest circle around the orange region is 25 centimeters. The circle around the green region is 35 centimeters. And now the question is, given this scenario and a random throw, what is the expected value of the number of points we win by throwing a dart? So for that, we're going to have to find all the probabilities where we cannot count cases because there are just too many points. We can proceed using areas. So the area of the blue region is the area of a circle with radius 10 centimeters. And so the formula is pi r squared. So we have 100 pi centimeters squared. And this is a problem interesting in the sense that you will see an example when going beyond this to go to decimal is sort of a waste of our efforts. Now let's find the orange region. The orange region is this little ring, and we can get the area of this region if we just take the area of this circle, and from that we subtract the whole that is the blue region. The second biggest circle has radius 25 centimeters, so it's pi times 25 centimeter squared. That's the entire area, and from that we subtract the blue, which is still the same, pi times 100 centimeters squared. So what we have is 625 pi centimeters squared minus 100 pi centimeters squared. So we have 525 pi squared centimeter. That would be the area of the orange region. The area of the green region can also be found as a difference of two circles. We take the area of the largest circle, and from that we subtract the area of the circle around the orange region. So that would be pi times 35 centimeters squared minus pi times the middle circle. 35 squared is 1,225, so we have 1,225 pi square centimeters minus 625 pi square centimeters. So that seems to be 600. Because we're gonna compute probabilities, one more data we need is the total area, sort of the all possibilities. And that would be the area of this big circle, which we have computed here, is 1,225 pi many square centimeters. And that also means that if we add these three, we should get the total area, right? So let's see, 6, yes. So it looks like so far on the right track. So now that we have the areas, let's figure out the probabilities. The probability of landing green is the area of the green region, which is 600 pi centimeters squared, divided by the total area, which is 1,225 pi centimeters squared. And now you see we have cancellation. We cancel out pi. If we were to multiply 600 and pi and 1,225 and pi, we would lose precision, and for no good reason whatsoever, because pi cancels out. You might not get this clean, nice fraction if you just use 600 pi and 1,225 pi. So in this case, it's good to stay with the abstract. So we have a fraction that's less than 1. That's always encouraging in case of a probability. Both seem to be divisible by 25. 600 is 24 times 25, and 1,225 is 49 times 25. So we think that the probability of landing on the green region is 24/49. All right, let's see the next one. What is the probability of landing on an orange point? So the orange area is 525 pi square centimeters, and the total area is not going to change, it's 1225 pi centimeters squared. And let us notice that we're always going to be able to simplify by 25 because the radii 10, 25, 35, they're all divisible by 5, and then after squaring, we're dealing with numbers that are divisible by 25. So every single number here, they're all divisible by 25. So if we divide by 25 again, we get 21 in the numerator and the same 49 in the denominator. So the probability of landing on an orange field is 21/49. Finally, the probability of landing on a blue spot is, well, the blue area is 100 pi square centimeters, and the total area is still the same, 1225 pi centimeters squared. Again, we can cancel out the units, we can cancel out pi and 25, and then we get 4 in the numerator and 49 in the denominator. And assuming that the dart always hits the board, that means that every single outcome is listed here, so this probability should add up to 1. Do they? 24 plus 4 is 24 plus 21 is 45 plus 4 is 49. So these three fractions add up to 49/49. So that's good news. So now recall what the point values were. If we hit green point on the dartboard, that's 1 point. Landing an orange point gets us 5 points, and the blue region is going to be worth 10 points if we land there. So the expected value of the score is, well, we list every outcome with its probabilities. So 24 times out of 49, we're going to get 1 point. 21 times out of 49, we're going to get 5 points. And 4 times out of 49, we're going to get 10 points. So if we keep the common denominator to be 49, in the numerator, we will get 24 plus 105 plus 40, and that is 169 divided by 49. So this is the exact value of the expected value of the points. And if you perform the division, we get the decimal 3.448979. Thank you for watching.